Chain isomerism or skeletal isomerism. What is chain isomerism? Organic compounds that have the same molecular formula but different structural formulas are called skeletal isomerisms. So, same molecular formula but different structural formula. In this example, let write the molecular formula of each of these compounds. This one contains 1, 2, 3, 4, 5, 6, 7 carbon atom, and it's saturated carbon atom, so it's C7H16. This one contains also 7, and this one contains also 7. So all these compounds have the same molecular formula, but they have different structural formula and they have different name. This is one represents the heptane, this is one represent the 2-methylhexane, and this is one the 2-dimethylpentane, because this is the main chain which contain 5 atoms of carbon. So this is pentane, and we have 2-methyl group, and each one occupies the carbon number 2. We have 2, 2 hyphen dimethyls, since we have 2-methyl group, and pentane. So these hydrocarbons or these alkanes are isomers, skeletal isomers. Why? Because they have different structural formula but same molecular formula. Which of these following alkanes are skeletal isomers? To know, we want to find the molecular formula of each one. This one contains 5 carbon atoms, so it's C5H12. This one contains 6, so it's C6H14. This one contains 7, and this one 5, 6, and 5. So the first example, A and D and F are skeletal isomers since they have different structural formula but same molecular formula. And B and C are also isomers since they have different structural formula but same molecular formula. Now we will talk about the reactivity of an alkane. The first, all alkane can undergo complete combustion. What is complete combustion? Is the reaction between an alkane and an excess of oxygen to produce carbon dioxide and water according to the general following equation. So this equation is the general equation of the combustion of alkane. It's also for memorizing. So the second reaction that alkane can undergo, so first all alkanes can undergo combustion reaction and also substitution reaction. What is substitution reaction? When a halogen and an alkane are exposed to sunlight, a substitution reaction that takes place between them. In this reaction, a halogen replaces a hydrogen in the alkane. So we have a halogen that replaces a hydrogen. So let us take the following example, the substitution reaction of methane by chlorine gas. The following reaction, we have here the methane, 1 carbon and 4 hydrogen, with the chlorine gas, which is Cl2, under the sunlight. Look at the product obtained. We have here 4 hydrogen. In the product, we have 3 hydrogen, but the hydrogen that is taken here is replaced by a halogen, and in addition of this product, we have hydrogen chloride, which is produced. So this reaction can continue by replacing all the hydrogen in the molecule by the following reaction. If on the product obtained with 3 hydrogen and 1 chlorine, we add another molecule of chlorine gas, the second hydrogen is replaced by a second chlorine gas and a HCl is produced. This one, the substitution reaction, can continue also by replacing the third hydrogen, and we have three chlorine gas which take the place of three hydrogen, and at the end the last hydrogen is replaced and tetrachloromethane is obtained. The following reaction can be the following. We can add directly 2 molecules of chlorine, and in this case 2 hydrogen atoms are replaced to obtain CH2Cl2. This reaction is called dichlorination because we add 2 molecules of chlorine and we obtain 2 hydrogen are replaced directly. We can add directly 3 molecules of chlorine or another halogen to replace 3 hydrogen at the same time, and we can add 4 molecule of chlorine to replace 4 hydrogen. So the number of hydrogen replaced is equal to the number of halogen added. If we add 2, we can replace 2 hydrogen. If we had 4 bromine or chlorine or iodine, any halogen, we can replace 4 hydrogen. So how can the product obtained in these reactions are called haloalkane or alkyl halide. What is a haloalkane or alkyl halide? Is obtained when at least a halogen replaces a hydrogen of the main chain of an alkane. The name of the obtained haloalkane is determined in the same way that of branched alkane, where halogen are considered as branches. So the same steps followed before to name a branched chain alkane are followed to name a haloalkane, and the halogen is considered as a ramification or branch or branched. So, but if we have bromine in the haloalkane, it's called bromo. If we have chlorine, it's called chloro, iodine, iodo, fluorine, fluoro. Let's apply the rule taken in this example. Here, the main chain is the following: 1, 2, 3, 4. We have 4 carbon atoms, so it's butane. The branches are the following: chlorine, chlorine, and bromine. Let's number the main chain. We have here, if we start by this extremity, we have 1, 2. In carbon 2, we have bromine and chlorine, 2, 2. And here we have chlorine 3. So in this direction we have 2, 2, 3. If we start here, we have 2 also for chlorine, but we have 3, 3. 2, 2 and 3, 2, 3, 3. So this direction is to be adopted. So by starting by this direction, we have chlorine and bromine. Since B comes before C in the alphabetical order, we must name bromo before chloro. So it's 2 bromo and 2, 3. Since each chlorine is attached to a given carbon, 2, 3, dichloro and butane. This is our chapter for these